Welcome to This Explainer. Today we're diving straight into what has to be one of the most bizarre paradoxes in climate science, how record-breaking global heat could actually push Europe into a modern-day ice age. I know, it sounds totally counterintuitive, right? Like how in the world can a planet that is literally warming up everywhere suddenly trigger a deep freeze in one specific region? Well, it isn't science fiction, it's a very real possibility, and it all comes down to the delicate, hidden balance of our oceans.
So climate and ocean scientists have been sounding the alarm on this apparent contradiction for decades now. When we think about global warming, our minds naturally jump to extreme heat waves, melting ice caps, and rising sea levels. Basically, things getting hotter. But nature's systems are wildly complex and totally interconnected. A huge spike in temperature in one part of the world can actually shut down vital, invisible climate engines somewhere else. And that can lead to some drastically unexpected rapid cooling.
To really grasp this geographical mystery, think about Calgary in Canada and Frankfurt in Germany. Both of these cities sit at the exact same latitude, 51 degrees north. They are the exact same distance from the North Pole and the same distance from the equator. Yet there is a staggering 20 degrees Celsius difference in their winter temperatures. While Calgary plunges to a freezing, bitter minus 12 degrees, Frankfurt is sitting there enjoying a relatively mild 8 degrees.
And we see this exact same anomaly further south too. Take New York and Madrid, both right at 40 degrees north. New York regularly drops below freezing in the winter, hitting minus 2 degrees, while Madrid sits comfortably at a low of 4 degrees. Honestly, if you match up any city in North America with its counterpart at the same latitude in Europe, Europe is somehow artificially kept way, way warmer. Without this hidden mechanism, Europe should logically be just as freezing as parts of Canada. So what is this hidden engine pulling the strings?
Section 1. The Ocean's Conveyor Belt. The invisible engine warming Europe. To solve this massive temperature mystery, we have to look deep, deep beneath the surface of the Atlantic Ocean. There is an incredible invisible engine down there, called the AMOC, that stands for the Atlantic Meridional Overturning Circulation. This single, planetary-scale ocean current is practically entirely responsible for Europe's pleasant climate. Think of it like a gigantic global conveyor belt that is constantly moving water and, more importantly, pumping massive amounts of heat across the planet.
This invisible engine creates a continuous, thousands of years-long loop that pulls heat straight from the equator all the way up to Europe. It starts as warm surface water traveling north towards Greenland. When it gets there, icy winds cause the water to evaporate and sea ice to form. The water that's left behind sinks deep down to the ocean floor, travels all the way south to Antarctica, gets pushed back up, warms up near the Gulf of Mexico, and then sweeps back past Europe, delivering all that trapped heat before starting the whole cycle over again. It's a beautifully balanced system.
Now, the absolutely crucial ingredient for this whole engine to work is a fascinating phenomenon called brine rejection, which happens right up near Greenland. When the surface ocean water gets cold enough to freeze into solid sea ice, the physical ice structure actually doesn't have room for salt. So it forcibly expels or rejects the salt right out into the surrounding liquid water.
Because that rejected salt drastically lowers the freezing point of the surrounding water, it gets intensely cold, dropping to minus 2 degrees Celsius. But crucially, it doesn't freeze. It remains liquid. This creates ultra-salty, freezing water that becomes incredibly dense and heavy. And that sheer weight causes it to sink thousands of meters straight down to the ocean floor, which physically pulls more warm water in behind it to replace it. That sinking action? That is the literal heartbeat fueling this massive AMOC conveyor belt.
Section 2. How the engine breaks. The threat of fresh water.
Well, here is where global warming crashes the party and threatens to dismantle this perfectly balanced machine. I want you to really think about this. What happens when rising global temperatures start melting the vast, ancient ice sheets of Greenland? Remember, all that glacial ice is made entirely of fresh water.
You get a massive influx of fresh water from those melting glaciers pouring directly into the North Atlantic. It literally dilutes the ocean's salt concentration. And at the exact same time, warmer temperatures mean less sea ice is forming in the first place, meaning way less brine rejection is happening. Without that high concentration of salt, the water just doesn't get heavy enough to sink anymore. And if the water stops sinking, the conveyor belt loses its engine. It could literally stop the ocean's global heat transfer dead in its tracks.
Section 3. The hard evidence, tracking the slowdown in real time. The scary part is scientists aren't just guessing about this threat. Since 2004, a highly complex underwater sensor system known as the Rapid Array has been tracking this exact data all the way from the Bahamas to the Canary Islands. They are measuring temperature, pressure, and flow rates thousands of meters underwater. To understand the data they're pulling, researchers measure the AMOX flow using a unit called the Sverdrup. To wrap your head around that scale, one single Sverdrup is equal to 1 billion liters of ocean water flowing every single second. It is a completely mind-boggling volume of water.
And the data they're getting reveals something extremely concerning. Back in 2004, the AMOC flow was measured at roughly 18.5 Sverdrups. Today, it has dropped to about 16 Sverdrups. A major 2025 geophysical research paper noted that the flow is currently dropping by about 1 Sverdrup per decade. And if it hits the critical threshold of 6 Sverdrups, the entire system enters a full shutdown phase.
So let's put that into perspective. That represents a staggering 16% reduction in the AMOC flow over just the last 20 years. And this isn't just a sudden, one-off drop. The data shows a consistent, year-over-year downward trend. The engine is demonstrably, measurably slowing down as we speak.
And thermal satellite images absolutely back this up. If you look at thermal heat maps of our planet right now, basically the entire globe is painted in warm oranges and reds, showing rising temperatures everywhere. Everywhere, that is, except for one highly unusual white and blue patch, what scientists call a cold blob, sitting right in the ocean near Greenland. It's the only place on Earth currently cooling down. This proves that the warm currents from the south are failing to arrive and cold glacial meltwater is taking over.
Section 4. The Younger Dryas Precedent. History repeating itself.
Now, we know this kind of catastrophic shutdown is possible because paleoclimatologists tell us it has happened exactly like this before. 12,000 years ago, at the very end of the last ice age, long before human fossil fuels ever existed, natural global warming started melting massive ice sheets across North America and Europe. This flooded the Atlantic with fresh water, diluted the ocean's salt, and completely broke the AMOC cycle. The result? Without that warm water flowing up from the equator, Europe's average temperature plummeted by 5 to 10 degrees Celsius, plunging the entire continent into a brutal deep freeze for a whole millennium.
And how do we know this for sure? Well, researchers confirmed this icy era by drilling deep into the Earth. They discovered pollen from a specific Arctic flower called the dryas, a tough little plant that normally only survives in extreme Arctic circles, buried deep beneath what is now temperate Europe, dating back exactly to this period. That is why this historical deep freeze is officially known today as the Younger Dryas.
Section 5. The Modern Ice Age. The catastrophic finale of an AMOC collapse.
So what exactly happens to humanity if this cycle breaks again, but in our modern era? Honestly, we're looking at a terrifying domino effect, where everyday life in Europe is totally upended. Cities like London and Dublin, which are used to mild, rainy winters, would suddenly plunge to -15 or -20 degrees Celsius. Vital trade ports would freeze completely solid all year round. Northern European agriculture would fail completely. Energy grids would easily collapse under the unprecedented demand for winter heating. This would likely trigger the largest climate migration in human history, turning former host nations into climate refugees forced to migrate to Spain, Italy, or North Africa just to survive.
And it's not just Europe that pays the price. Remember, the AMOC is a conveyor belt that moves heat away from the equator. If that belt stops moving, the heat that normally travels north will just get trapped down in the southern hemisphere. This means regions like South America, the South Atlantic, and Africa will suffer from devastating, trapped extreme heat. They'll practically be baking whole continents alive while Europe freezes over.
You see, global warming isn't just about things getting universally hotter everywhere. It's about disrupting the incredibly delicate invisible systems that make human civilization possible in the first place. As this invisible conveyor belt continues to slow down, measured drop by drop in the cold waters off Greenland, we really have to ask ourselves, will we heed nature's delicate warning before this massive climate disaster becomes our inescapable reality? Thank you for joining me on this explainer. I hope this gives you a completely new perspective on our planet's oceans and the hidden engines keeping us alive. Keep learning, and I'll see you next time.